Welcome to College Algebra. In this lecture video, we're going to talk a little bit more about linear and quadratic functions. Alright, so the first objective, let's take a look at linear functions. As you can recall from the previous lecture video, when we talk about linear functions, has the form of f of x equal to mx plus b. Okay, and we know linear function always provide us with a straight line. Alright, remember now, vertical line is actually not a function. Okay, vertical line is not a function. So when we say straight line, it's other than vertical lines. Alright, so as you can recall, y equal to mx plus b, where m is our slope and the b is the y value of the y-intercept. So what we want to do here is be able to find our linear function. Okay, so to do so, we will need a slope of the function and a point on the line, or to find the linear function, all we need is at least 2 points on the line. So for example, okay, we're trying to find the linear function. So when f of 0 is equal to -3, what that means is x is 0, okay, and f of x is my y value. So if I know my x is 0, that means this -3 got to be the y value. So this piece of information is telling us the given point is 0, -3. And the slope of the function, okay, is going to be -5. Alright, so to find the linear function, we just go back to the slope intercept form, y equal to mx plus b. So my m, so far what I got, my m is going to be -5 x plus b. Alright, b is the y value of the y-intercept. So if you look at this point, 0, -3, this point is actually the y-intercept. But for right now, what I'm going to show you is this. I'm going to put a b right here, and I'm going to solve for b. So earlier, when x is equal to 0, we say y is -3. So that means -5 times, use my point given, substitute for my x and the y, so I can solve for b. So -5 times 0 plus b will equal to the y, which is -3. So as you can see, -5 times 0 is 0. So my b, the y value of the y-intercept, is still going to be -3. So my function f of x, my linear function f of x, is just going to be -5x minus 3. Okay, that's all it is. So this is something you done back in beginning algebra. Here we just, instead of writing the y equal, we just write f of x equal. Alright, now let's take a look at same thing, finding a linear function, except this time the problem give me 2 points. Okay, because f of x, right, now my x has become -6. So the output is -7. That's referring to my y value. The other point, x is -3. The output into the function will be -10. So the problem gave me 2 points. So if I'm having 2 points, I will still need a slope. Okay, and to find b, I would just need one of the 2 points in a minute. So let's find slope. As you can recall, the slope formula, y2 minus y1 over x2 minus x1. So it does not really matter who is x1, y1, x2, y2. It doesn't really matter. We just label one of them as x1, y1. So I'm just going to do the first one as x1, y1. Second point as x2, y2. Alright, I'm going to put it into my formula. y2 negative 10 minus, be careful, y1, what's y1? Negative 7. So that would be negative 10 subtract negative 7 over x2 is negative 3 minus x1. X1 is negative 6. So that will be subtracting a negative 6. So this is going to become negative 10 plus 7, which is negative 3 over positive 3. So my slope of my linear function is going to be negative 1. Alright, now to find the b, I would just need one of the 2 points. So far I should have negative 1 times x plus b. Alright, y equals mx plus b. I'm only going to use one of the 2 points. I'm going to use the first one. And it doesn't matter, you can pick either one. The answer should be this. The answer will be the same. Alright, so substitute x for negative 6. Output got to be the y value negative 7. So that will be negative 7 equals negative 1 times negative 6 plus b. Alright, so solve for b. This is going to be negative 7 equal to positive 6 plus b. So if I move my positive 6 over, my y-intercept or the y value of the y-intercept will be negative 13. Alright, positive 6 move over, become negative. Alright, therefore my function f of x, my linear function, which is turned out to be slope negative 1x. Cannot type in 1, okay, in front of the x in the Hawks Learning. You won't take it for some reason. Minus 13. Alright, so just a couple examples on the linear function. Most of us know about our linear functions. But now, what I really want to focus on in this particular lecture video is our quadratic functions. Okay, but let me do a couple more examples. I got a couple more where we got to do some graphing here. This is pretty easy. Find the slope and the y-intercept. Express an intercept as an ordered pair. Be careful right here, okay? The y-intercept is considered as a point on the line, so we're going to write them as an ordered pair. So if you think about y equal to, or f of x equal to mx plus b, that means my m got to be negative 2/5, right? mx plus b. So my slope, I'm going to put it right down here, okay? My slope got to be that negative 2/5. My y-intercept, this number negative 2 is the y value of the y-intercept. So if you say negative 2 for y-intercept, it's actually incorrect. You got to write them as a coordinate. So you got to say that's 0, negative 2. Okay. As you can recall, y-intercept is a point where the line crosses over the y-axis. And on the y-axis, all the x values are 0. Alright, plot 2 points on the line and graph the function. So we can put this in the calculator and you can extract the 2 points. Let me just go ahead and give it a try. I'm just going to put it in real quick. If you want to do it this way, you can. Negative 2 minus parentheses 2/5. Close the parenthesis and press X. And I can graph it. Okay, this line going down the hill got negative slope. Let me go back to zoom standard. So the 2 points, you can just kind of go to the table and pick the 2 points. You can say 0, negative 2, and I normally choose whole number points. Okay, I always choose whole number points. And 5, negative 4. Okay, no problem. If you don't want to use the calculator way, you can just plot your y-intercept, which is 0, negative 2. So starting at the origin, go down 2, and use your slope to go to the next whole number point. The slope says negative 2/5. That means down 2 to the right 5. from the point we just plotted. Down 2 to the right 5. There you go. So this second point will be 5, -4. So those are the 2 points you can enter in. What did I say? 5, -4. Okay, that's all it is. I believe once you key in the 2 points, the computer will draw the line for you. Okay, so if you want to use the decimal point from the calculator, you can. You just got to enter two points. All right. This is another linear function. It's just written. You know, it did not quite written as exactly y equal mx plus b. So we're gonna simplify this real quick, so I can see what my slope is, what my y-intercept is. Alright, I see they've got 2 terms. My -1 will do a distribution. My first term, there's nothing in front, so that must be a +1 will do a distribution. Alright, so I should have still 4x -14. -1 times -12, +12. -1 times +7x, -7x. So when I combine like term here, my function a of x is going to be -3x minus 2. So my slope will be -3, y equal mx plus b. So my b is the y value of the y-intercept. So that'll be 0, -2 again. Oops, sorry. Well, let me go get one of them points. You know what, I can do one right here. So if I plot my y-intercept 0, -2 right here, then follow my slope to the next whole number point. So that'll be -3 over 1. So that's down 3 to the right 1. So this must be the next point on the line. So the first point I plotted was 0, -2. My second point will be 1, -5. Those are the 2 points. Or you can just put this in the graphing calculator to extract your 2 points. Nothing hard, nothing hard. Oops. A little bit crooked there. Alright. Let's do some quadratic functions, okay? Objective number 2, quadratic functions. Okay. Quadratic functions, as I mentioned before, has the form of f of x equal to ax squared plus bx plus c. There's another general form, which is actually f of x equal to a times parenthesis x minus h whole thing squared plus k. This is just another form for quadratic functions. Alright, so let me explain some of these concepts with you real quick. So the most basic quadratic function will be x squared, and as you can recall, quadratic function provides with a parabola, which is a u. So I'm gonna go ahead and graph this real quick so I can show you. Alright, so here's my u, the most basic parabola we can have. Alright, so I know my u is open upward right now, so this side keep on going left and up, this side keep on going right and up, so my domain got to be from -infinity to +infinity, like I mentioned before. Alright. And the most basic parabola, x squared, is actually the lowest point is actually centered at the origin. Okay, so let's scroll down here a little bit. So the graph of a quadratic function is called parabola. We mentioned that before. Now the very bottom or the very top of a parabola is called the vertex. So this very bottom point right now is called the vertex, which we don't say x and y value, we just call them h and k. So in the general form, this number will be h, this number will be k. So what do I mean by very bottom or very top? Because sometimes I can get a parabola open downward. So if I open downward, the very top will becomes my vertex. Alright, if I open upwards, the very bottom point will be my vertex. So I will begin to use the word vertex rather than say the very top or very bottom. Alright, the very bottom, okay, in application type of problem, okay, my vertex is called the absolute minimum. So when we're talking about the absolute minimum, we are referring to the y value. Okay, we can say, where does the minimum occur? That will be the x value. What is the minimum? That's referring to the y value. If my parabola open downward, then my vertex will become the absolute maximum. That's the highest point of my parabola. So the maximum will be referring to what is the maximum of my parabola. That's referring to the y value. Okay, and as you can see, parabola, quadratic function, this parabola is symmetrical. Okay, that means one half of the parabola is mirror image with the other half. Okay, that means I can actually fold this right hand side over, okay, to the left side. Okay, fold along the y-axis. That's called a mirror image. All right, the axis of symmetry, okay, is referring to the vertical line that will actually goes through the vertex. The axis of symmetry. Right now, my axis of symmetry for this problem is actually referring to the y-axis. Okay, so here on the side here, I'm gonna kind of draw this for you. Okay, so if I have a parabola, it's not where the vertex is not at the origin. If my vertex is not at the origin, then an axis symmetry will be a vertical line that pass through the vertex. And as you can recall, vertical line has an equation that says x equal to a number. So that number will be the same x value as what's on the vertex. Okay, that's called the axis of symmetry. Alright, so for this example, I got my vertex at 0, 0, axis of symmetry, x equal to 0, right? The same x value. Right, my domain is negative infinity to infinity. My range, okay, since my minimum is 0, go from down up. That will be from 0, keep on going up to infinity. Alright, I'm using a bracket for 0 because my origin is actually a point on my parabola. Alright, furthermore, the letter A. The A is referring to the leading coefficient, okay, in both forms. If that leading coefficient is greater than 0, another way of saying greater than 0 means positive. If that A is a positive, then the parabola will open upward. Just like this one, the one I drew earlier. What's in front of the X is a positive 1. So that positive sign will tell me my parabola open upward. If I were insert a negative 1, then my parabola will open downward. Alright. If that number A, okay, the first two up here is for the signs. If that number A is anything between 0 to 1, okay, anything between 0 to 1 is referring to 0 point something. 0 point something convert into a fraction will be referring to proper fractions. So if this number A is a proper fraction, then my parabola will open wide. So I'm gonna graph the original one, x squared. Down here on the y2, I'm gonna do a 1 over 2. You know, half is between 0 and 1, which is 0.5. X to the second power. And I'm gonna come here to the very left, make a double line. So the darker one is my half x squared. And here we go. This is the original one. Open wider means what? It's a little bit on the outside. Open wide is referring to the y value did not go up as high, because whatever my x is, I'm actually divided by 2. I'm actually times a half. Therefore, my y value is always half. Okay, compared to the original one. That's why it opened wider. Alright, if that number in front of the x squared, if the leading coefficient is more than 1, okay, like a 2 for example, so I'm going to put delete, delete, delete. I'm going to just do a 2x squared. It will open narrower compared to the regular x squared, because that's referring to the y value actually shoots up quicker than the regular x squared one. Regular x squared, and that's the 2x squared. The y value shoots up faster. Okay, that's what it means, you know. So these four things here is looking at the signs and the numerical value of the leading coefficient. It does affect what the parabola is doing. All right. And earlier I mentioned the vertex is h and k for the general form. All right. So if I'm having a quadratic function that's in this form, ax squared plus bx plus c, then to find its vertex, we can use the vertex formula. Okay. So the h, or the x value, is simply negative b over 2a. The k, or the y value, will be, take the x value. Think about this, okay? If my x value is already the x value of the vertex, and when I substitute my x value back into my function, therefore the output got to be the y value of my vertex. Okay, that's why the formula says f of negative b over 2a. All right. One more thing I would like to go over with you before we do an example will be the x-intercepts. As you can recall, x-intercept is referring to a point. Oh Lord, got a big old tablet. X-intercept is where the graph crosses over the x-axis. Or excuse me, that's right. It's a point where the graph crosses over the x-axis. And you say, what's a big deal? Let me just draw a parabola right here. What is a big deal about my graph cross over the x-axis? Well, when we cross over the x-axis, the y value on the x-axis is always 0. So to find x-intercept means we will solve for x when the y is equal to 0. So finding x-intercept is like finding the zeros of a function. Okay, we'll talk more about this later on, but it's not going to be quite exactly the same. Alright, so before, in other video I mentioned, okay, quadratic equation has this form where we set equal to 0. Why did we set equal to 0? That 0 here is referring to y is equal to 0. So our job was to find x when y equal to 0. So that was the same thing as saying finding the x-intercept. Alright, so when we used to have my quadratic equation set equal to 0, and now I'm having a quadratic function where f of x is equal to ax squared plus bxc. So if we put the two together, that means this part is a quadratic equation, this part is a quadratic function. So if f of x is equal to this and this is equal to 0, that means my f of x is equal to 0. That's referring to y is equal to 0. So to find x-intercept, all we have to do is set my entire function equal to 0 and solve for x. Okay, that's how we made the connection between the equations and the graphs. As a matter of fact, if I go back up here, this equation, okay, my function was, this linear function was negative 3x minus 2. So if I will set my y equal to 0, if I will set my y equal to 0 and solve for x, that will give me my x-intercept, which is negative, move this over, divided by 3, negative 2/3. Okay, so finding x-intercept is the same as solving for x. Okay, it's actually mean the same thing. Alright, let's put everything about parabola together. Okay, so this one is in the general form. Okay, this quadratic function is written in general form. So let me copy my form real quick. There's something I want to show you. Okay, go by, if we purely go by the formula. Okay, this is the general form, and here is what? Here is my function. Okay, the form, if you're matching up all the letters, a down here is 1, x match with x, subtraction sign match with subtraction sign, therefore h match up with 5. Okay, so the k, okay, is actually going to be entire negative 4, because that's a positive sign. Alright, think about that. If everything matches up, h here got to be 5, because the formula calls for what? Calls for subtraction sign. So if you already got it, that means your h is actually positive. Alright, the k is always going to be positive. So if you have a negative 4, that negative 4 is the k. So my vertex, 5 comma negative 4. Alright, let's find the x-intercept real quick. So to find x-intercept, we set our function equal to 0. Alright, this is only 2 terms. So as we mentioned before in the review, if my quadratic equation only got 2 terms, I can use the square root property. So I'm going to move my negative 4 over, and that will give me 4 equals x minus 5 whole thing squared. Now if I apply the square root property, all I'm going to do is take a square root on both sides. So that means my answer will simply be x minus 5 equal to, when I take a square root on both sides, my answer is always positive and negative. Square root of 4 is 2. Now I'll move my negative 5 over to get x by itself. Then my problem will become positive 5 plus 2, which is 7, or positive 5 minus 2, which is 3. Okay, so express intercept as ordered pairs. So my true x-intercept means find x when y equal to 0. So that will be 3. My x is 3 comma 0, or excuse me, not or, and 7 comma 0. And I got my vertex up here, so I'm gonna, you know what, I'm gonna just copy it and move it down here. There we go. There we go. Alright, find 2 points on the graph of the parabola other than the vertex and the intercepts. Okay, so this is actually referring to 2 additional points. Okay, and the reason we need to find 2 additional points so we can actually have our graph a little more accurate. Alright, so I'm going to go ahead and plot these 3 so far that we already come up with. So, vertex 5, -4. 5, -4 is right here. 3, 0. 1, 2, 3. 7, 0. Okay, so it turns out if you look at this vertex right here, 5, -4. So earlier we're talking about the axis of symmetry. That means there's a vertical line that will come through here. Okay, and that vertical line, I'm gonna draw it, but I'm gonna erase it. Okay, so there's this vertical line. The axis of symmetry divide my parabola into 2 halves. And we said parabola is symmetric. That means the right side and the left side are the same. That also tells us that the distance from one point to the left of the symmetry, 1 point from the right to the axis of symmetry, going to be the same distance. Okay, so from 3 to the axis, from 7 to the axis is actually the same distance. Okay, so one way to help us to find just 2 points on the graph, other than I just put it on the calculator, okay, is by picking another 2 points. So let's say I'm gonna do 2 points away from 7. 2 points away from 7. I'm gonna do 2 points away, 2 points to the right of 7, so that'll be 9. If I do 2 points to the left of 3, that'll be 1. And these 2 y values will be exactly the same. Okay, because it's got to be equal distance going back to the to the axis of symmetry. So if I will plug in 9 back into the original function, 9 minus 4, excuse me, 9 minus 5. 9 minus 5 squared, then minus 4. Okay, that's 4 squared, 16. 16 minus 4, 12. Okay. Now, I'm not going to plot 12 here because it's outside of my, it's way up here. So, that's not good for me as far as right now, plotting it on the graph for you. So tell you what, I'm going to do 1 distance to the axis of symmetry. I'm going to be in the middle of it. So 1 place to the right of 3 is 4. 1 place to the left of 7 is 6. Okay, I can still show you the y value is the same. Alright, so I'm going to, rather than have my 9 earlier minus 5 minus 4, I'm going to do 4 minus 5 squared minus 4. Give me -3. I can plot that. And I'm going to use 6. Watch this. Replacing x with the 6 now. Booyah. -3 again. The y values got to be the same. Okay, because they are symmetric. Equal distance to the x values are equal distance to the axis of symmetry. So the y value is going to be the same. Alright, so your 2 points can be 4, -3, 6, -3, or any other ones that you come up with by entering the function into the graphing calculator. So 4, -3 will be about right here. 6, -3. So right 6 down 3, I'll be right there. And here's my parabola. you go. Okay. Oops, not very pretty, but you get the point. All right. Let's try another one. This one, same thing. All right. So if you're comparing the form, here for a minute. Okay. My vertex. Okay. A is -1. This is actually -1 here. Okay. A is 1, but the sign is negative. So that tells me before I even graph it that my parabola will open down. Okay. The formula called for subtraction, but this is a plus sign. Why this is a plus sign when it's supposed to be subtraction sign here? Well, it's a plus sign because I am subtracting a -1. Right? So that means my h is actually a -1. So that's why a lot of times students says h is the opposite sign. That's the reason why it's the opposite sign. All right? K is the same sign. That's how students say it. So that'll be -4. All right, that's my vertex. All right, whatever you do here, okay, do not multiply this thing out when you're finding the x-intercepts. Okay, it makes it too much work. So let's set my function equal to 0. And let's do the x-intercept. Use the square root property because technically you only got 2 terms. All right, same step as previously. -4 come over, become +4. Now I am not going to take a square root on both sides right now, including a negative. So if I would times both sides or divide both sides by this -1, that will actually make this 4 negative. And this side would just be +x plus 1, whole thing squared. Alright, so now when I take a square root on both sides, I should get simply x plus 1, square and square root canceled out, equal to positive and negative. Square root of 4 is 2, square root of -1 is an I. Okay. Alright, move my x over. So my x is equal to -1 plus minus 2i. Okay. So, find the x-intercept. X-intercept is where the line crosses over the x-axis. If I will graph this parabola, negative parenthesis x plus 1 whole thing squared and then -4, we know the parabola will open down, but look at the picture. Did it ever cross over the x-axis? Nope. It never crossed over the x-axis because my answer here, when I'm solving for the x-intercept, I end up with an I. I is imaginary number where it does not exist on the real number line, and that shows it right here that this graph, okay, never have any x-intercept. All right. So find x-intercept, we got none. But remember earlier I mentioned something about where was it? Right here. Finding x-intercept is like finding the zero of a function, but not exactly the same. So what we just did is actually finding the zeros of a function, which is not quite finding x-intercept, because my x-intercept is actually none. I don't have any. Okay, but I do still have zeros of a function, but I don't have any x-intercepts. All right, we can still graph this. We just got to use different points. Okay, so we can extract points. Okay, from here. Let me go back here real quick. Okay, remember the vertex -1, -4. -1, -4. I'll show you this. So the axis of symmetry, -1, -4 is right here. The axis of symmetry. If I go one place to the right, one place to the left of my axis of symmetry, or away from my vertex. See right here, one place to the right, one place to the left for x value. The y values are exactly the same. Okay, so you could type in -2, -5, 0, -5, and that will actually draw the parabola for you. Okay, and you can use any points. You don't have to use the one I wrote. So there is a difference between finding x-intercept versus finding the zeros. How you do it is the same, but if your answer end up with an I, that clearly states you don't have any x-intercept. Alright, let's try a different one. Okay, what happens if it's in this form? How do I find the vertex? And now this is where the vertex formula will come in play. Okay, -b over 2a is the h. So in this form, we need to know the a, the b, and just the a and the b. We don't need the c. So a, the leading coefficient is 1. Alright, the b is +6. I'm going to write the c while I'm at it. Alright, so my h, or the x value, is the same as -b over 2a. So that would be -6 over 2 times my a, 1. So that's basically -6 over 2, which is -3. So this -3 is an x value of the vertex. So if I take this same x value of the vertex, plug it back into the function, then the output got to be the y value of the vertex. So that my k would just be f of my -3. Plus 6 times -3 plus 8. And a different way you can do it. Once you know the h is -3, graph the function, then you just look up -3. It just sometimes, what if the h is not a whole number? You can still figure this out by hand. What's that? X squared plus 6x plus 8. Alright, here's my parabola. Ooh, I do cross over the x-intercept twice. X-axis twice. So if I go to -3, my y value is -1. So I know k is going to be -1. Alright, that's my vertex. Now, problems are very easy when things are whole numbers, but it's not always going to be the case. Find the x-intercept. Find x-intercept means find the x value when the y values are 0. So here is 1. -2, 0 is 1 x-intercept. The other one, where's the other one? Where is the other one? -1 and -3, right? 1, 2, -4. Where is it? Did I miss it? There you go, right there. Okay, -2 and -4. Alright, things are a lot easier when it is whole number. And you can definitely extract other 2 points from the table to actually draw your the parabola. Alright, but I'm still gonna go over this, okay? To find the x-intercept, set my y value equal to 0. Okay, set my function equal to 0. Plus 6x plus 8. Alright, to solve quadratic equation here, the first thing we should try is always by factoring. If you cannot factor this, then you got to use a quadratic formula. So x and x, for 8 we can use 2 and 4. Oh, did I wrote it down wrong? Yeah, it is -2. Sorry about that. I wrote that wrong. -2. To end up with a positive 6 in the middle, I got to have both of them positive. If I set each factor equal to 0, my x is equal to -2, the other x is equal to -4. Alright. Just be careful, okay? Be careful when your x-intercept is not a whole number for x value. Then factor it will be necessary, okay? Because calculator does not really do a very good job displaying. The table does not display. Table does not really display decimal numbers. It definitely does not display fractions. There are other ways we can do in a calculator that can give me my x-intercept in decimal form, but then convert it to fraction form. Sometimes that's kind of hard because certain decimal doesn't really show all the repeating patterns. So that's why, you know, knowing how to do it by hand is still important, still crucial. Alright, by looking at that leading coefficient, I know my parabola is about to open downward. Alright, finding the vertex. Negative b over 2a. Let's give it a try. -1, b is 6. C is -m. So my h, or my x value of the vertex, negative b over 2a. That'll be negative 6 over 2 times -1. So that will be basically negative 6 over -2, which is positive 3. Alright, so if I substitute my 3 back into the function to get my k, to get my y value of the vertex. Alright, if I plug it in, that'll be negative parenthesis 3 squared plus 6x, which is 6 times 3 minus 8. Now give me my k. Alright, I'm going to go ahead and graph it too, okay, just in a minute. Negative parenthesis 3 squared plus 6 times 3 minus 8. 1, positive 1. Alright, so my vertex, 3, 1. Alright, I'm going to see if I'm going to see this picture, see if it will cross over the x-axis, okay? Maybe, maybe not. Negative x to the second power plus 6x minus 8. Oh, yes it does, right there. Very good. Alright, so without looking at the table, because to look at the table, I'm looking for the y value equal to 0. I'm just going to do this one, negative x squared plus 6x minus 8. Alright, I'm going to try to factor this one, okay? I don't want my leading term to be negative, so I will factor out a -1. So that'll give me positive x squared minus 6x plus 8. So this time, to get rid of this -1, I just divide both sides by -1. So I can just simply have 0 equal to x squared minus 6x plus 8. So this one, just like the previous one, where I can use 2 and 4 for my 8. But my signs since the middle term is a -6, both of these gotta be negative. So if I set each factor equal to 0, my x is equal to 2, the other one equal to 4. So my x-intercept, 2, positive 2 comma 0, positive 4 comma 0. So thank goodness, okay, thank goodness it's a whole number. So if you ever come here, excuse me, if you ever come to the table where you cannot find y value equal to 0, okay, that tell you that well, take a step back. If you do see the graph cross over the x-axis where you do have x-intercept, but then when you come to the table and don't see any x value matching up with a 0 for y, that tell you right away your x-intercept could be what? Could be a fraction, okay? Some sort of fraction, some sort of rational number. That's probably a better wording for it. That's some type of rational number, or we might have to do by factoring or by using quadratic formula to solve it. Okay, just in case if you run into it. Alrighty, so get additional 2 more points, okay, and then graph the parabola. Alright, we're gonna end this video here. For part 2 of this section, we're gonna do some application problem. Alright, thank you for watching.